Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. So today we come to our second asynchronous class, which is for week number 3. Following what we have discussed last week, okay, so now we are in chapter 1 part 2. Okay, chapter 1 part 2. So basically last week we have done with the introduction. Alright, part 1, eigenvalues and eigenvectors, right? Okay, I expect, okay, all of you know how to find the eigenvalues and also the eigenvectors. Alright, and if you remember during our synchronous class, okay, we did discuss about the 9 properties of eigenvalues problems, kan? Kita ada relation lambda 1, lambda 2 which is equals to the trace of lambda 1 tambah lambda 2 is equals to trace of A, lambda 1 times with lambda 2 equals to determinant of A, and then lambda lambda for matrix A to the power of K is equals to lambda of A to the power of K and all, right? Okay, so all of you, those who miss our Google Meet class, so please make sure you viewed the recorded Google Meet class last week. Alright, so for today, we are going to discuss, okay, this. I think for today's learning outcome, we are actually going to continue discussing the property. If in part 1 we stopped at property number 9, so now we're going to continue for the remaining property. Okay, so I guess for today's asynchronous lecture, the learning outcome is make sure all of you understand how do we define as linearly independent eigenvectors and how to determine the eigenvalues for n equals to 3. Okay, for n equals to 3 means the size of the matrix itself. Kalau sebelum ni kita find the eigenvalue and eigenvectors for a matrix A 2 times 2 matrix, right? For example 1, 2, 3, 4 lah. Saya suka guna 1, 2, 3, 4 kan. So for today, for n equals to 3, meaning we are going to find the eigenvalue and eigenvectors for size 3 times 3. So maknanya 1, 2, 3, 4, 5, 6, 7, 8, 9 for example je ni. Okay, so this is going to be for today, and if time permits, okay, basically we will have a look at also for this symmetry and skew symmetry and orthogonal matrix. So we will see. Okay, saya tak guarantee yang ni. Okay, we will check it out whether we do have enough time or not. Okay, and for sure eigenbase and diagonalization is in our next class. Okay, so now we move to property number 10. Okay, so what does it mean by property number 10 here? If we have lambda 1, lambda 2, okay, basically class, n here is the size of the matrix. Alright, before this we have n equals to 2, meaning we have 2 times 2 matrix, 1, 2, 3, 4, right? So you have 2 times 2 matrix. And how many lambda normally we get? We get 2 lambda, right? Lambda 1 and lambda 2. So meaning to say, the size of the matrix will determine how many eigenvalues that you will get. And that eigenvalue, for each of the eigenvalue, you will have its eigenvectors, right? So as stated in property number 10 here, lambda 1, lambda 2 up to lambda k, where k can be less than or equals to n, are the simple eigenvalues in the list with corresponding eigenvectors. Okay, each of this lambda, it has its eigenvectors, kan? Eigenvectors for lambda 1, eigenvectors for lambda 2. So the relation between eigenvector for lambda 1 and lambda 2 should be linearly independent. Okay, linearly independent. So we will discuss in further what does it mean by linearly independent very soon. Okay, and then for property 11, if lambda is an eigenvalue of multiplicity k more than 1, then Okay, lambda we have anywhere from 1 to k linearly independent eigenvectors. Ni maksudnya kat sini, lambda ni kan there is one example macam kalau kita consider kita solve, kita dapat lambda minus 1 equals to 0. So meaning we have lambda equals to 1. So it multiplicity more than 1. It's repeated. Okay, so this one we will have linearly independent eigenvectors as well. Okay, we will have a look through example. Okay, so how to say that, okay, it is linearly independent. Okay, saya kata tadi this x1 ni, for example, x1 ni adalah eigenvector for lambda 1, x2 adalah eigenvector for lambda 2 and so on. Katakanlah kita ada up to n kan, lambda tu. So this is up to n eigenvectors. Then you may put the eigenvectors in a form of matrices to show that all these vectors are linearly independent. What you can do is put them in terms of a matrix and try to find its determinant. If the determinant of this matrix X, which is combine all the eigenvectors, is not equal to 0, then the n vectors inside this matrix or the n eigenvectors here are linearly independent. Tapi kalau you find its determinant and you find out that its determinant is equal to 0, then meaning to say the eigenvectors kat dalam ni are linearly dependent. So maknanya there's something wrong with your eigenvectors sebenarnya. Alright, so because by right it's supposed to be linearly independent. Alright, okay, done with that. Now let's try example number 6a. Okay, let's try example number 6a. So, meaning to say the linear outcome for today, it come parallelly. Kita nak fahamkan pasal eigenvectors are linearly independent, and at the same time we are going to learn how to solve the eigenvalue problem for n equals to 3. Apa maksud n equals to 3 ni? Matrix ni is 3 times 3. Alright, so let's try to solve example 6a. Okay, so for this example 6a, saya buat kat sini. So the matrix is as this. So to find its lambda, so of course first of all untuk find its lambda, kita buat dalam bentuk a minus lambda I, right? So for this case, meaning to say lambda I kat kita sekarang akan jadi, because the size of matrix A now is 3 times 3, so lambda I will be also 3 times 3. Okay, 3 times 3. So maknanya kat sini lambda 0, 0, 0, lambda 0, 0, 0, lambda, right? Okay, there you go. So A minus lambda I will be, determinant of this will be 1 tolak lambda. Nampak? 1 tolak lambda ni. A minus lambda I. This is matrix A. This is lambda I. So tolak. This matrix tolak sekali. Okay, tolak. So 1 tolak lambda, negative 1 minus with 0. So it remain as negative 1. 0 pun 0 lah. 0 tolak 0. So negative 1, second row minus 0. And then 2 minus lambda for the second row, second column. Then negative 1 minus 0 for the second row, third column. Then 0 minus 0, negative 1 minus 0. 1 tolak lambda. Right? And then from here, then you can evaluate this determinant lah. Okay, you may now evaluate this determinant. So, apa yang kita dapat? Ni you have to be careful lah macam mana nak kira determinant for 3 times 3 matrix. Ni again revision to all of you lah. So, kita tolak ni kan. First row, first column. Okay, first row, first column tolak ni. So, 1 minus lambda, saya guna biru. 1 minus lambda darab dengan 2 minus lambda darab ni. Besar sikit. 2 minus lambda darab dengan 1 tolak lambda minus with ni minus 1. So, tolak 1 je lah. Okay. And then minus, okay, second row kan dia positif negatif, so minus kat sini, minus with second row, okay, yang second time, the second element, first row, second column, kita tolak second column, ingat tak, to find the determinant of 3 times 3 matrix. So this one is negative 1 darab dengan negative 1, yang ni darab dengan yang ni kan. Okay, this one with this one, negative 1 darab dengan 1 minus lambda. Okay, and then fortunately yang second dia kosong, betul tak? Tolak kosong, so minus with 0, tak ada apalah, minus with 0. And then the third one also luckily 0 juga, nampak ni kan, third 0, so tak payah dah lah. Okay, hopefully you all clear lah what I'm talking about. Okay, so now kita akan dapat 1 minus lambda. Kat sini kita ada 2 minus lambda, 1 tolak lambda, okay, minus 1. And then for the second one, you're going to have plus 1 minus lambda. Okay, nampak? Okay, plus negatif, ni tolak ni. Okay, negatif jadi positif, tapi kat dalam ni masih lagi ada tolak kan, minus. Okay, so minus 1 minus lambda equals to 0. Okay, minus yang ni, hopefully all of you understand yang ni. Ni negatif positif, ni kat dalam ni ada satu lagi negatif ni. Okay, so minus. So as you can see here, you need to solve for lambda. So first hint is to solve for lambda, try cari common factor. So if you can see, there are two terms here, first term, second term. So both terms here we have 1 minus lambda, so you may factor out 1 minus lambda out. So kat sini kita akan ada 2 minus lambda, 1 tolak lambda ni tak difaktorkan lah sebab dia memang kat dalam. Okay, and then minus 1 minus 1 yang apa ni, yang kat sini, and then minus with 1 equals to 0. Alright, so from here you can try to solve. Okay, actually we already found one of the factor, tapi tak apa, kita biarkan dulu. 1 minus lambda ni biar je kat luar. We settle whatever we have inside here. So masukkan yang dalam ni. So you have 2 minus 2 lambda minus lambda plus with lambda square, right? Minus minus 1, and then we minus another 1 here, minus 1 kan, equals to 0. Tak muat lah pula. Okay, so as you can see here, 2 tolak 1 tolak 1, so kosong dah kat sini. So what will you have, sambung kat sini lah, hopefully you all tak confused Okay, saya sambung kat sini, sambung kat sini. So sekarang ni kita ada 1 minus lambda, yang ni 1 minus lambda yang ni, and then yang ni kita simplify dia jadi lambda square minus 3 lambda equals to 0. There you go. So nampak tak kat sini, what we have is we have 1 minus lambda, satu factor, another factor is lambda, and then another one is lambda minus 3 equals to 0. So from here we are going to have how many eigenvalues? Okay, from here we are going to have 3 eigenvalues, which are, one is lambda equals to 1, 0 and 3. Okay, we are going to have 3 eigenvalues, lambda equals to 1, lambda equals to 0, and lambda equals to 3. Those who are not clear with my working here, you can try on your own and find out whether will you get or not this all 3 eigenvalues. Alright, so with this, we're going to proceed next to find the eigenvectors. Okay, so now we want to find the eigenvector for this matrix A, knowing that we already found 3 eigenvalues. Lambda equals to 1, 0 and 3. So we'll proceed for first lambda equals to 1. Ingat tak cara macam mana kita nak cari ni? Kita substitute with 1 minus lambda tadi kan. Kat sini kan kita ada 1 minus lambda. So this one will be 1 minus 1, negative 1, 0. So negative 1, 2 kat sini kita minus with 1, which is 2 minus lambda tadi. Negative 1 and then 0, negative 1, 1 minus 1 right, 1 minus 1 because lambda equals to 1. Okay, and then this one maknanya sekarang ni kita ada x1, x2 and x3, and this one will be equals to 0, 0, 0, right? So what will you have here? 1 tarap dengan 1 is tulis mula je lah. 1 minus 1 with 0, negative 1, 0, negative 1, 1, negative 1, and then here 0, negative 1, 0. Right? So here we have x1, x2 and x3. Step by step dah ni saya tunjuk ni. 0, 0, 0. So if you multiply the matrix, okay, basically you will get apa? 0. Okay, 0 darab dengan x1, 0 lah. And then minus x2 equals to 0. That is the first line. And the second line, you will get negative x1, okay, plus with x2 minus with x3 equals to 0. Betul tak? Right? And then we will have, again, the third row pun sama. x1 plus minus x2. x1 times 0 minus x2 times 1 is minus x2. Yang ni darab dengan ni, kosong darab dengan x1, kosong. Minus 1 darab dengan x2 is minus x2. And then 0 darab dengan x3 will be 0 equals to 0. So basically, what we will have, directly kita dapat agak. Bukan, kita dapat tahu x2 is equals to 0. Nampak tak? So, bila x2 ni sama dengan kosong, then you can ganti x2 ni sama dengan kosong kat dalam ni. Then, what will you have? You will get negative x1 minus x3 equals to 0. Sebab x2 you dah ganti dengan kosong ni. Then, from here, you will have negative x1 is equals to x3. Right? So, in this case, you can assign any number as long as x1 and x3 ni dia in opposite sign. So katakanlah if I let x1 is negative 1, okay, x2 definitely 0, then my x3 will be 1. Clear? Or I can also buat x1 equals to 1, x2 0, x1 negative 1. Boleh juga. Okay, as long as x1 and x3 are in the opposite direction. Okay, hope I make you all clear lah. Okay, we're done with lambda equals to 1. So you just pilih lah mana-mana satu. Then if you want to prove, then go ahead. You can also prove that your answer is correct. Ax equals to lambda x tadi. Alright. Okay, now saya nak proceed for lambda equals to 0. Okay, tadi kita dah cari, this is the answer for lambda equals to 1 kan tadi. This is for lambda equals to 1, dia punya answer. Now, I'm going to proceed untuk cari jawapan untuk lambda equals to 0. So, untuk lambda equals to 0, maknanya kat sini 1 tolak 0, 2 tolak 0, negatif 1 tolak 0. Basically, tak berubah pun lah. Dia same matrix as matrix A je lah sebab lambda dia sama dengan 0. So, here you will have 1, 2, and 1. So if you multiply this, you will get x1 minus x2, okay, plus with x3 times 0, you will get 0. So basically kat sini it will give you x1 kena sama dengan x2. Alright, and then the second one, okay, minus x1 plus 2 x2, okay, and then minus x3 equals to 0. Yang ni macam Menarik sikit kan. And then the third one will give us 0 times x1 is 0, then minus x2 plus x3 equals to 0. Okay. So dari sini we have x1 is equals to x2, right? Okay, we have one equation. And then this one will give us x3 is equals to x2. Kita ada satu lagi equation. And then what we have here? Okay, x1 is equals to x2. So why not you ganti? x1 is equals to x2. Okay, yang ni kalau you ganti, x1 is equals to x2. So maknanya kat sini kalau kita ganti, kita akan dapat negative x2 tambah 2 x2 minus x3 equals to 0. There you go. You nampak tak? Negative x2 tambah 2x2, you akan dapat negative x2. Positive x2. Positive x2 is equals to x3. So maknanya, this is the equation. x1 sama dengan x2. x2 pula sama dengan x3. So, in conclusion, maknanya x1 sama dengan x2. Then, x2 pula sama dengan x3. Faham? So, maknanya all the three elements for the eigenvector for lambda equals to 0 will be any value. So, any value that will make all the elements equal. Maknanya kat sini, kalau nak senang, x1 equals to 1, x2 equals to 1, x3 equals to 1. Faham? Ataupun you tak nak 1, then you can choose 3, 3, 3 or 4, 4, 4 or negative 1, negative 1, negative 1. Up to you. So, untuk make my life easy, I just use 1, 1, 1 lah. Okay, kalau you tak nak, you boleh guna 2, 3, 3, 3, 4, 4, 4. As long as all the values are the same. Alright, class. So, now we're done with 1, we're done with 0. Now, let's proceed for 3. Okay, now for lambda equals to 3, maknanya kat sini untuk kira kita jadi 1 tolak 3, 2 tolak 3, then 1 minus 3 at the third row, third column. So, 1 tolak 3 will give you negative 2 kat sini, 2 tolak 3 kat tengah ni will give you negative 1, and 1 minus 3 will give you negative 2. Alright, and then from here, kita, macam biasalah, kita darab ni. So, you will get negative 2x1 minus x2, x3 kosong, so you will get equals to 0. So basically this one will give you x2 sama dengan negative 2 x1, right? x2 sama dengan negative 2 x1. Alright, and then this one you will get negative x1 minus x2 minus x3 equals to 0. And then the third one, you will have 0 times x1 is 0. Then minus x2 minus 2x3 equals to 0. Okay. So, cuba kita tengok. Ini kita dapat first equation. Yang second equation ni kan. So, we have minus x1. Okay. Minus x1. Kita ada minus x1. x2 ni cuba you ganti dengan minus 2x1. So, x2 kita ganti dengan minus 2x1. Okay, ganti dengan minus 2x1 minus x3 equals to 0. So, what you will get here, negative x1 plus with 2x1, then you will get x1 equals to negative x3 ni, tolak x3 ni tu pergi ke sana, you get x1 is equals to x3. Nampak? We get the second equation here, x1 equals to x3. The first equation is x1, s2 is equals to minus 2x1. And yang ketiga ni pula, okay, yang ketiga ni will give us apa? Yang ketiga ni will give us x2 is equals to 2x3. Betul? Okay, yang ketiga ni akan bagi kita, yang ni saya bawa ke sini, x2 is equals to x2 is equals to negative 2x3. Okay, yang ketiga ni adalah yang ni, x2 is equals to negative 2x3. So, kita ada 3 equation. So, what you want to let? So, basically, kalau kita tengok kat sini, x1 tu sebenarnya sama dengan x3. Whereas x2 tu adalah 2 kali x3 ataupun 2 kali x1. Sorry, negative. Okay, 2 times negative 2 times x1 and also x3. So basically for your lambda equals to 3 ni, you can let any number. Katakanlah kita let, let's say we let x1 sama dengan 1. Then with this, it will give us x3 also equals to 3. Sebab x1 is equals to x3. Then dari situ kita will find out what is our x2. X2 ni sama dengan negative 2 darab dengan x3 ataupun negative 2 darab dengan x1. Sama je x1 dengan x3 ni, which is 1. So maknanya kat sini our x2 is equals to negative 2. Nampak? Okay. So basically lambda eigenvector for lambda equals to 3 is in this pattern. 1, negative 2, 1. Tapi kalau you tak nak 1 negative, again, kalau you tak nak 1, negative 2, 1, you can choose, katakanlah kat sini you boleh buat 2, negative 4, 2. Ataupun you boleh juga buat negative 2, 4, negative 2. Okay, sebab negatif positif, faham tak? It's just a matter of what number you want to assign at first. Okay, x1 tu kalau positif maknanya x2 jadi negatif. Kalau x1 negatif, then x2 jadi positif. And then x3 akan sama dengan x1 lah, jadi negatif juga. Okay class, so basically kita dah cari the eigenvector for lambda equals to 3, lambda equals to 0, and lambda equals to 1. Now I'm going to show what does it mean by these 3 eigenvectors are linearly independent. Alright? Okay, to prove that these 3 eigenvectors are linearly independent, yang ada banyak pilihan, you pilih satu cukup lah. Okay, pilih satu cukup. Okay, right? Is we susun all the 3 vectors ni into a 3 times 3 matrix. Okay, katakan tak kisah nak letak eigenvector untuk lambda equals to 0 dulu ke, lambda equals to 1 dulu ke, lambda equals to 3 dulu ke, tak kisah. Macam saya ni, saya letak lambda equals to 0 dan saya letak lambda equals to 1, lambda equals to 3. Okay, so lambda equals to 0 tadi saya dapat 1, 1, 1. Okay, so I'm going to put here 1, 1, 1. Lambda equals to 1 is negative, saya pilih yang ni Okay, negative 1, 0, 1. You nak pilih yang ni pun tak apa, tak ada masalah. Okay, and for lambda equals to 3, I'm going to choose this one. Okay, 1, negative 2, 1. Alright, so now how we are going to show that it's linearly independent, all these 3 matrices are, you are to find the determinant. Cari determinant of this matrix. Okay, so very simple je yang ni, senang je ni. Find the determinant of this matrix. Okay, so mula-mula kita tutup yang ni, kita tutup yang ni. So 1 darab dengan kosong darab 1, kosong. Okay, then minus with negative 2, right? Okay, and then minus with minus 1. Jadi positif lah tu. Okay, minus with minus 1. Okay, and then the second one, kita tutup yang ni. 1 darab dengan 1, 1 tolak 2. So jadi tambah 2. Okay, tolak 1 darab dengan 1, tolak 2 tambah. Okay, and then tambah this one, third row, third column, tambah 1 kan. Okay, and then 1 darab 1 is 1 minus 1 times 0 is 0. Then you compute this one, what you will get. This one kosong, negative 2 tambah jadi positive 2, and then plus with 1 plus 2 is 3, and then plus 1. Basically kita tak nak tahu pun value ni. It's just that to show that the determinant is not equals to 0. So the determinant of x is not equals to 0. So meaning that, okay, eigenvectors are the eigenvectors for matrix A are linearly, okay, linearly, tak cukup tempat, independent. Okay, kan soalan dia to show that the eigenvectors are linearly independent. So we have shown here all the 3 eigenvectors. We put in a matrix, okay, 3 times 3 matrix. We call it as big X here. We find its determinant, and we found that its determinant is equals, it does not equals to 0. So maknanya they are linearly independent. Apa maksud linearly independent and independent ni? Maksud dia macam ni sebenarnya. Kalau dia, you nampak ni, negatif 1, 2, negatif 1. Yang ni 1, 1. Negatif 1, 0, 1. Yes, they are actually, kalau tengok daripada sini pun, dia adalah linearly independent. Kalau dia nearly dependent, maknanya, kalau yang ni kan, kita dapat apa ni, eigenvector for lambda equals to 0, 1, 1, 1. And happen, kita dapat lambda, for lambda equals to 3, dia punya vektor adalah 3, 3, 3. Ni we call this as linearly dependent. Sebabnya kita boleh lambda, for lambda equals to 1, eigenvector dia adalah lambda equals to 3, eigenvector for lambda equals to 3 ni, which is 3, 3, for example, 3, 3, 3 for example, adalah 3 kali eigenvector for lambda equals to 1. Nampak? Sebab, lambda equals to 0. Yang ni saya set for lambda equals to 0 kan. So lambda equals to 0, matrik dia 1, 1, 1. Lambda equals to 3, matrik dia 3, 3, 3. Maknanya ni dia ada relation dia. Is linearly independent. Lambda equals to the eigenvector for lambda equals to 3 adalah equals to 3 times lambda eigenvector for lambda equals to 0. Sebabnya lambda equals to 0 is 1, 1, 1. So dia ada relation. This is so called as linearly dependent. Tapi kalau you tengok yang ni, ketiga-tiga matrix yang kita ada kat sini, we can't come up with an equation like this. Okay, that is so called as linearly independent. Alright class, so quite long for this first video because saya tak nak tersekat-sekat. So hopefully you know how to find the eigenvalues and eigenvectors for 3 times 3 matrix, and you know how to prove the eigenvectors that we get for all the eigenvalues are linearly independent. Alright, see you in the next video.